Hey fourth graders, this is Mr. Fries and I have a math challenge for you. My challenge for you is to make a factorization diagram, kind of like the one I'm showing you right there. And it's an extra project. The best projects win a prize. So what's this all about? Well, I think of prime numbers as the building blocks of all numbers. Every number must come from another number. Now, when you build like Legos, yeah, it could just be a pile of Legos, but if you're creative, you can build some really, really brilliant things. And that's what I'm going to ask you to do. I'm going to ask you to be creative and artistic with math. So what's a factorization diagram? Well, there are two types of numbers. There are prime numbers and there are composite numbers. And in class, you're going to learn the difference between them. And all this is a visual diagram of prime and composite numbers. Now, what's interesting is they can only be structured in certain ways. So here's your challenge. You're going to create a unique factorization diagram for the numbers 1 through 30. I don't want yours looking like your friends. I want yours to look the way you want it to look. Prizes go to the best 5 diagrams. Be creative. And you can do them on anything you want. You can make a big poster. You can make a booklet, 1 page for each number. You could make a PowerPoint if you have a computer and like to use technology. Or you could do anything else. Remember, the more creative, the better. This project is due Friday, February 7th to your teacher. So you must be thinking math, art, those don't have anything to do with each other. So right now I want to show you a video clip of a guy who loves math and loves prime numbers explaining prime numbers to you. He's a radio host in Australia.
I fell in love with mathematics from the earliest of ages. I explained it to all my friends. Maths is beautiful. It's natural. It's everywhere. Numbers are the musical notes with which the symphony of the universe is written. The great Descartes said something quite similar. The universe is written in the mathematical language. And today, I want to show you one of those musical notes. A number so beautiful, so massive, I think it will blow your mind. Today we're going to talk about prime numbers. Most of you, I'm sure, remember that 6 is not prime because it's 2 times 3. 7 is prime because it's 1 times 7, but we can't break it down into any smaller chunks, or as we call them, factors. Now, a few things you might like to know about prime numbers. 1 is not prime. The proof of that is a great party trick that admittedly only works at certain parties. Another thing about primes, there is no final biggest prime number. They keep going on forever. We know there are an infinite number of primes due to the brilliant mathematician Euclid. Over thousands of years ago, he proved that for us. But the third thing about prime numbers, mathematicians have always wondered, well, at any given moment in time, what is the biggest prime that we know about? Today, we're going to hunt for that massive prime.
Now, your job is not going to be to hunt for massive prime numbers, which is what they use to make secret codes. It's going to be to draw beautiful pictures of these prime numbers. So let me explain how it works. This is a picture of 4. 4 can be grouped a couple ways. I can draw 4 as a group because 4 is made up of 2 groups of 2, or 2 times 2. I could group numbers in different ways. Here I have a group of 9, a group of 9, and a group of 9. So I have 3 groups of 9, which represent 27. Here I have a lot of groups of 2. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 groups of 2 is one of the ways I can represent 34. Now what I want you guys to do is be completely creative in how you make your project. So there's not just one ways to do these. If you think about the number 12, I could make 12 a bunch of different ways. Well, one way I could make 12 is I know 12 is made up of 2 times 6. So what I could do is I could make 2 groups of 6. So I'm going to make a group of 6 and then another group of 6. Again, I'm going to try and make them as even and as balanced as possible because that's what multiplication and division are, equal groups. Well, if I didn't want to do 2 groups of 6, I could do it differently. I could do 4 groups of 3. Because 4 times 3 is 12. Notice my groups have to be equal. Well, I could look at that the other way too, right? I could look at 3 groups of 4. And I could put them in any pattern I wanted. Just one way of looking at it. And that's a composite number. It's made up of prime numbers. Now I run into problems sometimes because 5. So if I take 5 smiley faces, well, can I make groups of 2? There's 2 groups of 2, but that guy doesn't have anybody to go with. So can I make a group of... No, those groups aren't equal. I can't do that. So when you have a prime number like 5, and 5 is prime because of 5 times 1, all my prime numbers can only be represented as a circle. I'm going to show you right now an interactive diagram of what a factorization diagram could look like. So we're going to look at the numbers 1 through 30 and watch to see which ones are circles and which ones get grouped together. Remember, said 1 isn't prime, so watch every number after that. 2, nope. 3, nope, but I can group 4. I can group 6. I can group 10 into 2 groups of 5, but when I get to 11, it's a circle. 13's a circle. So as you watch these numbers, certain ones can be grouped and certain ones can't be. The ones that can't be are prime. The ones that can be are composite. And it's going to be your job to make pictures that show these different groupings or show a circle for prime numbers. I'm going to stop at 30 here. What they've done with 30 is he's made 5 groups of 6. 5 times 6 is 30. So 4th graders, accept the challenge. We want you to do more math and to make math artistic and art math-tastic. Accept the challenge, 4th graders.